Hi Year 11, this is a video on quadratic identities. Alright, so the basic idea with identities is that we have two quadratic expressions, so two quadratic equations that are equal to each other. And the way we know that they're equal, they're identical, is that we have the three horizontal lines to say that they're equal. So for example, if I had the equation 3x squared plus 2x plus 4, and I said that it was identical to this general equation, ax squared plus bx plus c, I can conclude that the coefficients of each of the terms are the same. So that means a must be 3, b must be 2, because the coefficient of x on either side is 2, and c must be 4. So when we have quadratic identities, so things that are identical to each other, the coefficients of each of the terms are equal, and that's the basis. As soon as you see the three equal signs, the three horizontal lines, you know that you're talking about two expressions where the coefficients are equal. Okay, so everything is built upon the principle that the coefficients will be equal, but the questions don't always ask us that. So we're going to start with the right-hand side, which is a x minus 1 all squared plus b x minus 1 plus c. We want to make it look like the left-hand side. So we're going to expand everything out. Now we've got x minus 1 all squared. So if we expand that out, we get x squared minus 2x plus 1. And then expanding out the next set of brackets, bx minus b. And then plus c. All right, next step. A little bit more expanding. Ax squared minus 2ax plus a, and then the rest is already expanded, plus bx plus c. Now remember, these are identities, so we want this to look like this. So next step is to get our terms that are similar together. So the ax squared is going to be by itself. So we want it to be something x squared plus something x plus c. So ax squared stays the same. But now I'm going to look for my x's, and there's two lots of them here. I'm going to factorise out the x. So taking out an x from the first term leaves negative 2a, and then I get b. And then the rest, all those other terms, make up my c here. So often you'll find c is made up of a few different letters. Okay, so we have ax squared. I'm just going to change the order of this next term around. Not essential, but I'm going to do that. b minus 2ax plus a minus b plus c. We're halfway there. We're in the form of a quadratic expression. And because it's an identity, I can conclude that the coefficients are equal. So there's my a, my b is the coefficient of the x, so that's everything in that bracket. And then c, the last term, is whatever else is left there. So there's 3 letters. So that's my c. All right, so back to the question, and the question tells us that it's 2x squared minus 3x plus 5. So a is 2. Now b has to equal negative 3. The coefficients are going to be equal, but I know from my expansion that b minus 2a equals negative 3. So I've got an equation here. I already know what a is. A is 2. So I'm going to expand that and solve it, and I get b equals 1. All right, now my last term, c, is 5, and it's also equal to a minus b plus c. Now I already know what a is and b is, so now it's a bit of a substitution to find out what c is, mini equation, and it gives me c equals 4. Okay, so I found out what a is, found out what b is, found out what c is. And now I'm going to go back to my question, which was to write 2x squared plus 3x, so minus 3x plus 5 in the form of a, which is 2x minus 1 squared, plus b, which is just 1, so I don't need to write that, x minus 1, plus c, which is 4. And that's my answer. So I thought we'd just go through the steps that I did to work through that question. So the first thing was that we start with the right-hand side and we expand everything. So expanded it all out until we got it to a stage where we could group the terms to make it in the form of a quadratic equation. And that means that we have something in front of an x squared, something in front of an x, and a whole lot of stuff at the end. And you can have many terms there. You might have 1, you might have 3. Then what we did is we equated the coefficients to make 3 simultaneous equations. What that means is that we took the coefficient of our initial equation and let that equal our big A in our expanded equation. We took the coefficient here, the negative 3, and we let that equal our coefficient of the x. And then we took our last term and we let that equal our last term in our expanded form. And so we ended up with 3 simultaneous equations here, which we solved. So solve the simultaneous equations, and then the last step was to rewrite the equation in the form required by the question. Now each question will be different, but the process will be the same. Okay, find the values for a, b and c if x squared minus x is identical to, here's our clue, we're talking about quadratic identities, is identical to what's on the right hand side. So step 1, start with the right hand side and expand everything. So I've got a x squared plus 6x plus 9 plus bx plus c minus 1. Okay, so that's our first step done. Started with the right hand side. Actually, not quite, just need to expand a little bit further. Ax squared plus that's 6ax plus 9a plus bx plus c minus 1. Okay, first step done. Second step, group the terms so that you have this in the form of a quadratic equation. So that means you've got something in front of the x squared. You have something in front of the x, and that requires you to factorize. So factorizing out 6a plus b. And then you've got something at the end, which is just whatever's left over. So I've got 9a plus c minus 1 left over. Okay, so that's step 2 done. Step 3, equate the coefficients to make 3 simultaneous equations. Well, there's my a, there's my b, and all of that is my c. Having a look at our initial equation, which was x squared minus x, we have to be a little bit tricky with this one. X squared minus x, we're missing something there. We're missing a c, but it's actually just a 0. So a is 1, because it's a 1 in front of the x squared. B is negative 1, and c is 0. Okay, so we're going to make our simultaneous equations. Well, we already know that a is 1. Now let's look at our second term. We've got 6a plus b equals, well, the coefficient of x is negative 1. So if we know that a is 1, that means 6 plus b equals -1, b equals -7. So I've done 2 steps. Third equation, all of c, 9a plus c minus 1, so all of this part here, has to equal 0. So we know that a is 1, so that's 9, plus c minus 1 is 0, so c equals -8. Okay, now having a look back to the question, rewrite the equation in the form required by the question. Well, the question in this case just asks us for the values of a, b and c. So a is 1, b is -7 and c is -8. Now this third question is one that's completely different, but we do use the same process. We're finding the equation of a parabola that passes through 3 points. Now, we know because it's a parabola, it has to have a quadratic equation of the form y equals ax squared plus bx plus c. So that's our starting point. Now, we're given 3 points, and if those points lie on that equation, when we substitute the points in, we'll be able to find the values of a, b and c. So when x equals -1, y equals -3. So I'm substituting in and doing a little bit of simplifying. So -3 equals a minus b plus c. Okay, so that's my first equation. I'm going to expect to have some simultaneous equations here. Let's look at our second point. Now this point also lies on the parabola, which means that when we substitute it in, we'll be able to work out b and c and a. Okay, so we've substituted 0 in, and that makes it quite easy for us because it tells us that c equals 3, because a lots of 0 is 0, b lots of 0 is 0 as well. Okay, so we know c is 3. Now we're looking at the third point, 21, so y equals 21 when a equals 2. Sorry, when x equals 2. So substituting that in, so 21 equals 4a plus 2b. Now I already know that c is 3, so I can tidy that equation up a little bit, which gives me 18 equals 4a plus 2b. Okay, so that's my second equation, and my first equation is up here in number 1. I can actually do a little bit more tidying up with equation number 1 because I now know what c is. So let's do that first, it'll make that a bit easier. I've got -3 equals a minus b plus 3 because I know c is 3. So -6 equals a minus b. Okay, so simultaneous equations, my choice is elimination or substitution. I'm going to do substitution, but you can do elimination if you like. So a equals -6 plus b, and I'm going to do 1 into 2. So my second equation is down the bottom. So that gives me 18 equals 4 lots of a. Well, a is -6 plus b plus 2b. So now I'm going to solve for b. So -24 plus 4b plus 2b. And that's 42 equals 6b. And 6 sevens are 42, so b equals 7. So I've got c, I've got b, I need a now. So going back to my first equation, a equals -6 plus 7, which equals 1. Alright, so I have at the start my general equation for a parabola. And now I've worked out my values for a, b and c. So y equals, well, a is 1, so we just write x squared. 7x, b is 7, it's positive 7, and c is 3. So the parabola y equals x squared plus 7x plus 3 passes through all those 3 points that we've used. And you can test that by substituting into that equation.